how's it going, internet people? Back again for another Explosions Incorporated video blog. Okay, now some of you may have noticed I changed the title. Last week it was Science Talks, but that was because I was kind of in a rush and that was a really stupid but really quick and easy name I came up with. But Aaron and I talked about it, and the song that plays as the intro and the outro to all of these vlogs is a song he wrote called Man of Constant Science. And we thought, well, Constant Science is way cooler than Science Talk. So, from this day forward, the name of this vlog series will be Constant Science. Now, I know last week's was a little bit long, but I had a lot to say about Ebola and all that junk, so I'm going to try to keep today's short and sweet. Going to try to hit that 5-minute mark. But it's going to be hard because I'm talking about pretty much one of the coolest things happening in science today. Let's talk about the Rosetta spacecraft. Now, Rosetta, named for the Rosetta Stone, which, if you don't know, helped us decipher ancient Egyptian hieroglyphics by matching it up with ancient Greek script a couple of hundred years ago, is out orbiting a comet right now. The comet's official designation is really hard to say. Pair of Russian names. It's hold on, let me check. Comet 69P / Churyumov-Gerasimenko. I think that's how it's pronounced. Anyway, it's not easy. That's the name of that comet that it's orbiting right now. We sent spacecraft out to visit comets before. The Deep Impact mission a few years back actually smashed into a comet and sent some information home about what the comet was made up of. But this is the first time that anything is ever going to be landing on the surface of a comet. Now that's pretty impressive because Comet 67P, which is what I'm going to call it from now on, is only about 2.5 by 3 miles. It's kind of shaped like almost like a rubber duck in some of the early photographs. We've never landed anything on something that small before. Heck, we've never even landed on one of the larger asteroids. So this is really, really neat. When I say we, I want to clear this up. It's not NASA that sent this one out. And I'm not knocking NASA. They do great work, of course. It was the European Space Agency. A bunch of different countries got together to put Rosetta together. But Rosetta isn't the part that's landing, okay? Just to be clear, Rosetta is the spacecraft itself. The lander is a separate module called the Philae lander, named after a different artifact, an obelisk that was discovered with hieroglyphics on it as well. Hieroglyphics in Greek like the Rosetta Stone. Now this thing has been traveling through space for over 10 years. It launched in March of 2004. And it just arrived at its destination this past May, started orbiting the comet and sending back some really amazing pictures, like this one. Now here we can see the comet itself. Then there's this one. This is actually a picture of the landing site that they've decided on. Right now it's called Site J, but there's actually a contest at the European Space Agency's Rosetta website for you to suggest a new name for Site J, and I did myself. I suggested we named it Phaistos, after the Phaistos disk, which is an as yet undeciphered ancient script. I think it kind of goes along with the Rosetta Philae theme. Last picture. This one was just sent out a couple of days before I recorded this video. They called it a selfie. Okay, whatever, yeah, I get it. This is a shot of one of the solar panels of the Rosetta spacecraft itself with the Comet 67P, Russian name, off in the distance. Now, if this doesn't blow your mind, hopefully what I tell you next will. So this thing's been traveling out in space for about 10 years, a little more than 10 years. In fact, it was 10 years and 2 months before it made its rendezvous with Comet 67P. Now that's pretty impressive that we can shoot something out into space and after 10 years it actually does hit its target. That's pretty cool. But what's even cooler is that during those 10 years, not only did we aim at something 10 years in the future, and we had to take into account the movement of the spacecraft and the movement of the comet to make sure they hit the same space at the same time. In order to do that, the spacecraft had to make gravitational slingshot passes 4 times! 4 freaking times as it was looping around the orbits of Earth and Mars to try to hit this comet. It corrected its trajectory by stealing a little bit of Earth's gravitational energy 3 times, and it did it around Mars once. And the really interesting thing about Mars is that that one wasn't expected. They didn't know they were going to have to do it, and so because it was unplanned, it was kind of dangerous. They actually had to turn the entire spacecraft down into standby mode, essentially, because it wasn't going to be getting enough sun to power it while it was doing its gravitational slingshot. And for anybody who doesn't know, that's basically you kind of go as if you're almost going to orbit an object, and then you shoot past it. And as you shoot past it at just the right angle, you can steal a little bit of its orbital momentum, which slows the planet down infinitesimally, almost immeasurably, but will speed up something the size of this spacecraft a bajillion times. Now, that's not a real number, but you get what I mean. It makes it go really a whole lot faster, and it corrects the course as well. You have to aim at the Earth, and then Mars, and then the Earth at exactly the right place, so that all of those chained shots work perfectly after 10 freaking years to shoot this spacecraft into orbit around a comet that's only a couple of miles wide. Now, the Philae lander hasn't landed on the comet just yet. It's going to do that next month. The lander itself is about 1 square meter, and once it lands on Site J, or Phaistos if you're listening, European Space Agency, it's going to start testing for the building blocks of life. It's going to see what's in that comet, but it actually has some equipment on it specifically to look for things like amino acids and cool stuff like that. You want to pay attention to this, and I'll actually put the link to the European Space Agency's Rosetta website down below the video. Now, why do you want to pay attention to this one? Because it's really freaking cool. Humanity can shoot a tiny spacecraft 10 years across space with 4 different gravitational course corrections to land on a tiny, tiny comet at just the right time before it starts to completely vaporize as it hits close enough to the sun to blow off that long comet tail. Now, I should say, because of that, this mission isn't actually going to be very long. It's only going to be a few months, because by early to mid next year, that comet's going to be shedding so much gas, it'll be so close to the sun, that the instruments on the spacecraft and the lander won't be able to function anymore. But in those intervening few months, the data we're going to gather will be invaluable, and hopefully this will work as a proof of concept to land on things like asteroids in the future and see what they're made of, and maybe even bring a little something home with us, because, you know, mining asteroids could really tank the world gold market when you think about it. I don't know if that's good or bad. Probably bad in the short term. Anyway, thanks for watching. Be back, I don't know, next week, the week after, with something else. As last week, if you have a suggestion for content for a future vlog, please leave it in the comments below here. This has been Constant Science. I'm Don from Explosions Incorporated. Have a good whatever. 'Cause I'm